All right, you guys, I'm going to do this example of solving a linear system by graphing. So remember, the solution to a linear system is going to be the point of intersection of the graphs that are, of the lines that are in the system. So this system just has two lines, so we're looking for that single point of intersection, which, remember, that point can be represented as an ordered pair x comma y, which then if we take that ordered pair and substitute the value of x that we get into each of the equations and the value we get for y into each of the equations and simplify, we would have true statements in the first equation and the second equation, okay, meaning that that ordered pair would satisfy each of the equations and would be the solution. So to solve this system by graphing, I could graph from the equations are currently written in standard form, and I could graph each of the lines by finding the x and the y-intercepts, but I would prefer to change them into slope-intercept form, and I have a feeling that's what you guys would want to do too. So I'm going to use different colors. I'm going to label that equation 1, and this will be equation 2. And before I can graph, I'm going to change them into slope-intercept form. So I'll take equation 1 first. And remember to go from To go from standard form to slope-intercept form, we need to solve for y. We need to get y isolated by itself on one side of the equation. So to do that, I'm going to first subtract x from each side of the equation. So I will have 2y equals to negative x plus 6. And remember, slope-intercept form is y equals to mx plus b. So I'm going to write the negative x before I write the plus 6, just so that I'm closer to being in slope-intercept form. And I'm allowed to do that because of the commutative property of addition, right? A plus b is equal to b plus a. Okay, so to finish getting y by itself on the left-hand side of the equation, I'm going to divide by 2 on each side. So I'll have y is equal to negative 1/2 x plus 3. Okay, where I can see now easily that my slope will be negative 1/2 and the y-intercept will be 0, 3, and I can go ahead and graph that line. So starting at the y-intercept, 0, 3, and then using my slope of negative 1/2 to graph additional points, I can go down 1, right 2, down 1, right 2, down 1, right 2. And to extend in the negative direction, I'm going to do the opposite and go up 1, left 2, up 1, left 2, up 1, left 2. And because I'm in Notability, I can use the Notability magic to draw my straight line. That'll do. And remember, because we are going to have multiple graphs in the same xy plane, we also need to label our lines with our equation. So I'm going to label it with the equation that's in slope-intercept form, but you could label with the original equation if that's your preference. Just make sure that you're labeling. Okay, so now I'm going to take equation 2. And to solve for y and change to slope-intercept form, we can just subtract 3x from each side of the equation. So now we can see that the slope of this line will be negative 3, and the y-intercept will be 0, negative 2. So to graph, we can start at the y-intercept, and then use our slope of negative 3, so down 3, right 1, down 3, right 1. And then the opposite to go to the left, so up 3, left 1, up 3, left 1, up 3, left 1, up 3, left 1. And then again use the Notability straight line magic. Okay, labeling the equation. Oops, minus 2. Okay, so now looking at our graph, we can see that the point of intersection is this point right here, which can be represented by the ordered pair -2, 4. Okay, but we want to make sure we had to use some algebra here, right? We had to change our equations into slope-intercept form. So we're using properties of equality. And then graphing, and we want to make sure that we didn't make any errors. So let's make sure that we check our solution. By substituting -2 in for x in each of the equations and 4 in for y to make sure we get true statements. So -2 plus 2 times 4 equals to 6. When I simplify here, I would get -2 plus 8 equals to 6. And that 6 equals to 6, so that checks. And then for the second equation, remember you have to check in both equations because you could get a point that lies on one of the lines, but if there was a mistake, it might not lie on the other line. Okay, so -6 plus 4 equals to -2, and that checks. So our solution to this system is -2, 4, and we would say that because we have exactly one solution to this system, that it is a consistent system. Okay, so consistent system with the solution being -2, 4.